Hey guys, so today we are going to be talking about monomials and exponent rules. This is a brand new chapter. We're not going to be graphing lines. We're not going to be um, solving any equations or anything. All we're really going to be working on is the idea of simplifying. But we have not talked about monomials explicitly yet, so this should be a nice breath of fresh air from what we've been doing. So to start, let's talk about what a monomial is. A monomial is a number, a variable, or even it could be the product of two or more numbers and variables. And so I bold-faced product because I wanted to remind myself to tell you that product means to multiply. So I should not be seeing any other operation in my problems other than multiplication. In my monomials and multiplication. So in example 1, the 4 satisfies just the first part of the definition. It could just be a number. Example 2 is y, and that was satisfying the second part of the definition, which it could be just a variable. Example 3 is whenever I shove them both together, and remember that whenever I have a 4 and a y put side by side, it really does intend to show multiplication. We just don't put the symbol there. And then the other examples after that are other ways that we can show a bunch of multiplication. Again, note that there's no adding, no subtracting, and no division symbols in a monomial. So you're going to end up just seeing a bunch of multiplication. Looking at example 5, this is something that you might remember, but exponents, remember, are showing repeated multiplication. And so that x squared in example 5 is just showing x times x. So that still satisfies this product idea that a monomial only has multiplication in it. Some non-examples. So here are 4 things that would not be monomials. Example 1 is not a monomial because it has division with a variable in the bottom, and that is not okay. Non-example 2 is the 5x is separated from the y with a plus sign, and the definition of monomial is only for product. So that means that we should have only multiplication, and because of that plus sign there, it's no good. Example 3, same kind of reason. We have a minus sign there. And then example 4 is actually a weird example. You can't have negative exponents with a variable, and we'll talk about that later on in this chapter. But just know that that is not a monomial when you have a negative exponent. The first vocabulary term I'd like to talk about is the degree of a monomial. It's pretty simply put that it's just the sum of all of the exponents of the variables. And we know that sum means to add. So in this example, we are looking at, example 1, it says that we are looking at the exponents of all the variables. And so the exponent of the variable x is a 2, and the exponent of the variable y is a 3. And so all I do is sum or add those up, and that gets me then 5. So I would say that the degree of this monomial is 5. In this example, the degree here, I already have here is 8. This one might be a little confusing for you. So the exponent of the variable a is 4. The exponent of the c is 3. But we have to remind ourselves that this b actually has an exponent, and it would be a 1. So I would be adding up that imaginary 1 with the 4 and the 3, which then gets me the 8. So please make sure that you know if there is a variable without an exponent, it does intend to have an exponent of 1. All right, so that's the degree. Oops. Moving on, you are actually able to add or subtract monomials. You also can multiply and divide them. And then furthermore, we can exponentiate and square root. All of these operations, though, have different rules, so make sure that you are understanding the difference as we go through them. We're going to first discuss, though, a little bit more vocabulary so we can all have a common language whenever we are talking about these monomials. So at the top here, I have the expression x to the 4th written, and I have labeled that the x, although we do call it a variable, because it is in the bottom of our expression, we call that the base. And then the little 4 we know is called an exponent. So make sure whenever I use the word base, you know that I'm really referring to whatever's on the bottom of your expression. And I also am reiterating that an exponent shows repeated multiplication of your base. So x to the fourth really means that I'm multiplying that base of x 4 times. So it would be x times x times x times x. And that's called expanding. Okay, so whenever you take an exponent and you break it apart into all of its multiplication, that is expanding. Another example of expansion with the 3xy to the fourth, that would really mean 3 times x. There's only one x there because its exponent is a 1. And then I would expand out the y 4 times. And notice, again, this is all multiplication, which is what makes it a monomial. So there is some confusion sometimes when it comes to exponents versus coefficients. So while exponents show repeated multiplication of the base, coefficients actually show repeated addition of the base. So if you recall from the previous slide, I said that x to the fourth actually expands out to be x times x times x. But if I use 4 instead of an exponent, I use it as a coefficient. It actually is repeated addition. So 4x means x plus x plus x plus x. Okay. Now you can actually interpret the second example I had from the previous example or from the previous slide 2 different ways. So you can either expand out the 3xy to the fourth using only multiplication, because this 4 here, this exponent would then show you've got 4 different y's being multiplied. But you could also see that the 3 as the coefficient would mean that you have 3, hold on a second, you have 3 of these guys. But with the coefficient being 3 means repeated, or the coefficient means repeated addition. So I would be adding up 3 of these variables here, these monomials here. So it could mean 2 different things. Okay, so keep in mind that coefficients and exponents, they're totally different. They say something totally different about your expression. Exponents show repeated multiplication. Coefficients show repeated addition. That is important to know. And also the operations with them are going to be quite different. Okay, so let's talk about adding and subtracting them first. This will feel very familiar to you, but it will start to get a little muddy once I throw more operations at you. So make sure that you really just grab a hold of this and understand it completely. So adding or subtracting monomials, there are 2 rules that you have to remember. You need like bases and you need to have like exponents. And this would be what we call like terms. And we have talked about like terms already before, but we've never thrown in this idea of having an exponent. You also, second rule, can only add or subtract coefficients. The base and the exponent do not change. So your coefficients are what you're actually adding together, as long as you have like terms. Let's see how this works. Oh, man. All right, so here's a bunch of examples. So I have the rules over here. I'm kind of all over the place. I'm going to go ahead and move myself up if I can. Up here, yeah. So here are the rules, and I'm going to go through these each time we do a problem just to make sure that you understand why the answers are the way they are. So in my rules, in order for me to be able to subtract these, which is the operation of the problem, I need to have like bases. My bases are all the variables and exponents. So this monomial has a base of xy, and this monomial also has a base of xy. Their exponents are all 1s, so I know that these are called like terms. Next, to add them or subtract them, I am actually going to just combine the coefficients. And the coefficient is what actually, or the symbol here is what I do with the coefficient. So in this case, I'm doing 4 minus, and the coefficient here we know is a 1. So 4 minus 1 is what gets me the 3. Notice that my like term, the xy, is still in my final expression. So make sure that all you are doing is changing your coefficients. You should not be changing your base and your exponent, or what we call your like term. In example 2, our base is x and our exponent is 3. In this monomial, our base is x and our exponent is 3. So that means that these are also like terms. So again, the coefficients are what are getting added up. In this case, it's addition because of the plus sign. So 7 plus 4 gets me 11. And notice that my base of my exponent, or my like term, is just going to stay the same. We do not change that at all. Okay, in this problem here, my base is an x with my exponent of 2, but the base here is an x with an exponent of 1. These are not like terms. Therefore, I can't do anything with these two monomials. So as you can see, what I have written here at the beginning is the only thing I can do. It's already simplified, so I just rewrite it. Some people will write cannot be simplified, and that is also sufficient. Okay, so you can write that. Or, oops, I spelled that wrong. Or you can just rewrite the expression because you can't do anything with it. All right. In example 4, I'm going to go ahead and minimize this. We have a bunch of different monomials put together. So we've got this one that has an x to the 5th. And what I like to do is look at this term and search for any more of those. So this does not have an x to the 5th, so that would not be a like term, but this one does, x to the 5th. So these are like terms. And so again, I've got my like terms. Now all I do is I add or subtract my coefficient. Well, I'm doing subtraction here because of the minus in front of the 4. So I'm doing an 8 and a minus 4. You could, if you wanted to, do 8 plus negative 4, but remember how we've tried to iron that out of our vocabulary? I like to think of that subtraction as a subtraction in this problem, not as a negative. So I would do 8 minus 4, which then gives me this 4 here. So 8 minus 4 gives me 4. And then again, I've got that x to the 5th, which does not get changed at all. Now we also have the 2xy that I did not have any like terms for. So it just gets written in the back. So because I can't do anything with it, I don't change it at all. Okay? All right. So looking at this example, I'm looking for like terms again. So I start with this first one and I say, this y to the 3rd. Are there any other y to the 3rds that I see in the problem? This is not a y to the 3rd. This is not a y to the 3rd, but this is. So y to the 3rds can be combined. This 3 is the coefficient and a minus 5 is the coefficient for this y. So we are going to combine those by doing 3 minus 5, which would then end up giving me negative 2. Now keep in mind that our variable y to the 3rd does not change at all. So I would have negative 2 y to the 3rds. I also have another term here. I have a y. And if I notice in the next monomial, I also have a y. So these can be combined as well. This 6 plus, and then we know there's a 1 there, will then give us these two combined. So a 6 plus the 1 will give me a 7, a positive 7. So I write the plus sign. And then my like term was the y. In the next example, I have, in this one, I have an x and a y to the 3rd. This only has the y to the 3rd part, so I cannot actually combine these two together. They are not like terms because this does not have an x like this one does. Here is just a y to the 3rd. There are no monomials here that have just a y to the 3rd. It can't combine with this one, we already said, because this does not have an x. So it is the only y to the 3rd. And the x is the only monomial that has just an x. So none of these are actually like terms. So you cannot combine them at all. So again, you can either write cannot be simplified, or you can rewrite your monomials together like we did in example 3, where we don't change anything. Last example of adding or subtracting, and this is something that sometimes boggles people's minds. So in this problem, I have a monomial with a base a and a base b with exponents of 1. Here, I also have an ab, and also here. So I can actually combine all of these to make one answer. So I've got a 5, I've got a minus 2, and I've got a minus 3. When I do 5 minus 2 minus 3, it gives me 0. So actually, all of these totally cancel out. So some people will say, well, that's 0 and then AB. But remember that this technically means 0 times AB, which actually just comes out to be 0. So the only way that you're left with nothing is if the coefficients make 0. Then that would mean that you don't have any variables left over. Okay? So that is all for adding and subtracting. Tomorrow, we are going to look at multiplying monomials. Okay, there are different rules for that, but I'd like for you guys to go ahead and try the adding and the subtracting.